Hello everyone, I am Domingo C. Keniti Jr., a third year BS ECE student. So for today's video, we'll be discussing the similarities and differences between the BJT and FET. Here we have a brief outline of what we're going to discuss in this video. So we have the definition of BJT and FET, the schematic diagram, the construction, the operations, the key differences, similarities, and the applications. What is a BJT? Well, BJT stands for bipolar junction transistor. Bipolar means that the current flow is due to types of charge carriers, that is electrons and holes. So sa BJT naatay duha ka types of BJT, which is the NPN and the PNP transistor. Ang ato sa BJT are used for switching as well as amplifications of small signals. So mao ni ang naong sa ato ang BJT natay PNP napud tay NPN. So a BJT is made of three alternating layers of P-type and N-type semiconductor materials. NPN is made by sandwiching the P layer between the two N layers, while PNP is made by sandwiching N layer between the two P layers. So since there are three alternating layers, there are two PN junctions in a BJT transistor. Thus, the name junction transistor. So mo ni siya ato ang BJT no, natay junction sa ato ang PNP, naputay junction sa ato ang NPN. So imong base to emitter junction naputay collector base junction. What is FET? So FET stands for the field effect transistor. The current flow in FET is due to the flow of only one type of charge carrier, that is either electrons or holes. So ang katong kagaina ang BJT nato is bipolar siya kay duha ka type of charge ang naga-flow sa iya ha. Pero andrea sa FET nato isa ra ka buok ang naga-flow, which is either electrons ang mo-flow sa imong FET or holes ang mo-flow sa imong FET. So therefore, FET is also known as a unipolar transistor kay isa ra man siya ang mo-flow sa iya sa imong transistor. So there are two types of FET transistors na kay GFET, which is the junction FET, and the MOSFET, which is the metal oxide semiconductor FET. These transistors are also used for switching as well as amplifications in electronic circuits. So mo ni ang naong sa imuhang FET, na kay in-channel FET, na kay p-channel FET, and we also have na kay mga tulo ka terminals. So ang tulo ka terminal sa imong FET is moto ang drain, ang gate ug ang source. So based on its construction, FET is available in two types. We have the N channel or the P channel FET. The channel refers to the path for the flow of current from source to drain terminal. The carriers enters the channel through the source and leave out at the drain. So there are no PN junctions between the source and drain. The gate region is made from alternate materials as compared to the channel. The gate is reverse biased in order to form a depletion region so that the channel between the drain and source is formed, which leads to the current flow. So increasing the reverse bias voltage at the gate increases the depletion region, which results in the increasing the current flow. So therefore, the voltage at the gate is used to control the output current. And FET is also known as a voltage controlled current device. So next we have the transistor construction of BJT and FET. So in BJT construction, natay duha ka types ra ba og BJT transistor. We have the NPN o the PNP. So mo ni siya ang PNP nimo ag imong NPN. The three terminals of BJT transistors are named emitter, base, and collector. So mo ni siya na kay emitter, na kay base, na kay collector. So ang kanin siya dayang illustration is a common base kay Ang imuhang base may gikonekan sa imuhang duha ka terminal nga E ug ang imuhang C, which is the collector. So each terminal is connected with each layer of the transistor. The base is the middle layer that is most lightly doped layer of all. So imong base is slightly doped layer na siya. So that means ang imuhang base is gamay ra kayo ang maka-flow na current. While ang imong emitter o collector are both heavily doped, with the emitter comparatively heavily doped than the other, which is the collector. So ang imuhang emitter is mas dako pa siya current kaysa sa imuhang collector. So mao nang maka-come up ta og kanang emitter nimo is just the sum of the collector and the base. So by connecting the base collector junction in reverse and base emitter junction in the forward bias allows the flow of current. So based on the type of BJT, current entering through the base allows a current between the collector and emitter which is proportional to the base current. Therefore, BJT is also known as a current controlled current device. So we have the GFET construction. So naatay duha ka types of GFET transistor, which is kaduang P-channel o N-channel. So the basic construction of the N-channel GFET is depicted on the screen with the N-type material forming the channel between the embedded layers of P-type material. The top of the N-type channel is connected via an ohmic contact to a terminal known as the drain or D, while the bottom of the same material is connected via an ohmic contact to a terminal known as the source, which is S. And the two P-type materials are linked as well as the gate terminal. So in essence, the drain and source are connected to the ends of the N-type channel, while the gate is connected to the layers of P-type material. Under no bias condition, the GFET has two PN junctions in the absence of any applied potentials. As a result, as shown in the figure, each junction has a depletion region that resembles the same region of a diode under no bias condition. Remember that a depletion region lacks free carriers and thus cannot support conduction. So the working mechanism of GFET can be analogized as in figure below. So mo ni ay mo kaning murag gripo nimo, which is na kay source, na kay gate, na po kay drain. So we have the schematic diagram of BJT and FET. So as you can see, sa imong BJT na kay NPN o PNP. So ang kaninday siya nga schematic diagram is a common emitter because ang imuhang emitter is nakonektahan sa duha nimo ka terminal, which is your base and the collector, and also the emitter is connected to the ground. And diri naman sa imong FET naa kay drain, gate o source sa imong in channel, and sa imong P channel same ra gyapon siya na kay drain, gate o source. So transistor operations of BJT and FET. So the operations of PNP and NPN are the same except for the current flow. So same ra ang operation sa imong PNP o ang imong NPN except ang sa current flow sa imong BJT. So sa imong PNP, ang current flow nimo is from E to B and C. Pero ang imong sa NPN, current flow nimo is from B to C to E. As for that, both type will have the current equation, which is ang IE nimo is just equals to IB plus IC. Kay di ba ang imong IE is just mo man siya kanang pinaka highly doped, which means na siya pinakadako nga current. So that means ang imong IB is i-plus sa nimong IB o IC, makakuha na kag IE. So kadung akong ibalik gay na no nga atong schematic diagram para mapakita no sa inyo ang kaduang ang flow sa imong NPN o sa imong PNP. So ang flow sa imong NPN is from your collector and base padulong siya sa imong emitter, while sa imong PNP is pabaliktad siya, opposite ra siya sa imong PNP, which is from your emitter padulong siya dito sa imong base to collector. So we have the operations of NPN transistor. So mo ni ang NPN nimo. So the base emitter junction is forward biased by the DC source VEB and the collector base junction is reverse biased by the VCB. So ang emitter base junction nimo is naka-forward bias siya while ang imuhang base o imuhang collector is naka-reverse bias siya. So the depletion region, ang iyahang kabag-on sa imuhang depletion region at emitter and base junction is reduced and the depletion layer sa imuhang collector o base junction is increased. So the forward bias EB junction is forward bias, so the majority charge carriers, that is electrons, starts flowing toward the p-type base region as shown in the figure. So this flow of charge carriers constitutes the emitter current, i.e. So as we know that the base region is very thin and lightly doped, so the majority charge carriers, that is holes, is less in p side. Hence, the injected electrons into the base from the emitter side gets recombined with the holes of the base region. So this constitutes the base current IB. So from sa imuha daw IE, IE nimo pa daw kasi imong collector, ang imong N-type is, ang majority carrier nimo is ang imong electrons. So pag imo siya i-forward bias sa imong p-type, mo ang depletion region nimo is grabe kagamay. So that means ang majority carrier nimo is makapass through sa imong p-type material. So pag abot na pod sa imong base which is p-type material is ang majority carrier sa p-type is tiba ang holes. So that means pag imo siyang i-forward bias pa doon dito sa collector, dili siya maka-flow ang imuhang electrons padung dito sa other side sa imong collector. Di siya maka-flow dito kung imo siya i-forward bias ang imong base to collector. So dapat ang imong pattern is reverse bias nimo siya kay para ang majority carrier nimo sa imong p-type material is dili siya maka-flow padung dito sa imong collector. So pag imo siyang i-reverse bias, that means dili maka-flow ang imuhang majority carrier, pero ang mga minority carrier nimo which is electrons is maka-flow dito padulong sa imuhang collector. So mao na siya ang operation sa imong NPN transistor. So naputay operation sa imuhang PNP transistor which is exactly the opposite lang siya. So sa imuhang A, naga-show lang siya og kanang similar to a forward bias diode. So ang majority carriers nimo holes flows from E to B and the minority carriers which is ang imong electrons flows from B to E. So resulting in the small depletion region, this means that the current flows heavily from E to B. So motong maka-flow ang imong majority carriers padung sa imong N-type material which is sa imong base. And then diri sa imong B is it is very similar to a reverse bias diode. Only minority carriers which is ang madung holes nimo flows from B to C. So there are no majority carriers flows resulting in big depletion region. This means that the current flows lightly from E to B. So mo to akong giin nga ang imuhang minority carriers is makalusot siya padung dito sa imuhang collector. So mao ni siya. So from majority carriers sa imong p-type na kay mga holes diri ang holes nimo majority carriers nimo is holes padung siya sa base which is ang majority carriers sa imong base is is electrons. So pag imo siya i-reverse bias, di na to maka-flow dito padung sa imong collector ang katong mga electrons. So pero ang imong minority carriers which is yung holes nimo is makalusot siya. So ang imong goal ani is dapat ang imong kuasa to sa imong emitter nga material makalusot to siya dito sa imong collector. So the emitter base junction is forward bias, so motong gaina, and the base collector junction is reverse bias. So despite of the big depletion region at BC, the majority carriers along with the minority carriers will flow through region C, resulting in IE is approximately equal to IC. So usually milliamperes ang unit ani niya. Then very few minority carrier will flow to terminal B due to the minority carrier resulting in IB in only a few microamperes. So there are three commonly used configuration in BJT. So we have the common base configuration, common emitter configuration, the common collector configuration. So mo ni imong common base configuration. Ang imong base is nakakonect siya sa ground and mooy nakakonect ang imong emitter o ang imong collector sa imong base. So mo ni ang schematic diagram sa imong common base. And then, in CB configuration, the input terminal is between terminal E and B due to the ground at B. And the output terminal is fixed between the terminal C and B. So, ang imong input, as you can see, is sa imong from your emitter and sa imong base, while ang imong output is from your collector o sa imong base. So, kanin siya natay common emitter configuration. So, gibalira siya. Ang imuhang emitter na pod ang nahimong common, which means ginakonektan siya sa imuhang base o sa imuhang collector and is connected to the ground. So, man siya. And then, in CE configuration, the input terminal is between terminal B and E due to the ground at E. The output terminal is fixed between terminal C and E. So, mo ni input from B to E and your E to C. We also have the common collector configuration, which is ang imuhang common is ang imuhang collector. Mao siya nakakonect sa ground. In common collector configuration, the input terminal is between the terminal B and the C due to ground at C. So the output terminal is fixed between the terminal E and C. So ang imong input is imong B o C, while ang imong output is imong C o E. So we also have the operating region sa ato ang BJT. So pag ang imong transistor is in the active region, that means ang imong transistor is working as an amplifier. While pag nasiya sa imong transistor is nasiya sa saturation region, it means that it is acting like a switch. So the amplifier is walled on, there is current but little voltage. And pag imong transistor is nasa cut-off, so that means the amplifier is basically off but little current. Here we also have the transistor characteristic and parameters of your BJT. We have the beta. So beta represents the amplification factor of a transistor. So beta is sometimes referred to as HFE, a term used in transistor modeling calculations. So in DC mode, ang imuhang beta DC is equals ra siya sa imuhang output, which is ang imong IC, over sa imong input, which is IB. So in ECE mode, beta nimo is just the change in IC over the change in IB. While sa imong alpha, alpha is the ratio of IC to IE. So kung na siya imong alpha sa DC is just equals to the IC over IE. So ideally, ang imong alpha is equals to 1 ra na siya. Pero in reality, alpha nimo is between 0.9 or 0.0998. So ang alpha sub nimo in the AC mode is just equals ra siya sa change in IC over change in IE. We also have here the beta relationship between amplification factors, which is sa A. So mo na imong relationship sa imong beta o imong alpha, which is na kay alpha is equals to beta over beta plus 1 or beta is equals to alpha over alpha minus 1. We also have the relationship between the currents. So na kay IC is just equals to beta times your IB, and your IE is just equals to beta plus 1 times IB. We have now the operations of FET or GFET. So mao ni siya ang imong FET, diba? So gate are always in reverse bias. Hence, the gate current Ig is practically zero. The source terminal is always connected to the end of the drain supply, which provides the necessary carrier. In N-channel GFET source terminal is connected to the negative end of the drain voltage source. The electrons flow from the source to drain through the channel from D to S is started. So the current ID NEMO increases as VDS is increased from 0 onward. This relationship between VDS and ID is continuous till VDS reaches certain value called the pinch off or the VPO. So when VDS is equal to 0 and VGS NEMO is decreased from 0, the gate reverse bias increases the things of the region. So as the negative value of the VGS is increased as stage cones when the two deflections regions touch each other, in this conduction, the channel is said to be cut off. So now we have the key differences of the BGT and the FET. So as you can see, BGT stands for bipolar junction transistor while FET stands for field effect transistor. So the current flow in BGT is due to the flow of majority as well as the minority carriers. While sa imuhang FET is the current flow is due to the flow of majority charge carriers. So so on. So makita man nato diri na ang mga differences sa ato ang BGT and FET. So mani ang kalahian sa to ang BJT o FET. Sa imuhang BJT na kay current flow at its base terminal while sa imuhang FET is negligible current at its base terminal. And ang imuhang BJT is suitable for low input current application while ang imuhang FET is suitable for low input voltage application. So now we have the similarities of BJT and FET. Now, the similarities of BJT and FET is that they are both three-terminal devices. They are also both active devices made up of semiconductor. BJT and FET, along with some passive devices, are used for amplifier design. Ang BJT po mo ang FET are used for switching mechanism and have three regions of operation. Both have also the same packaging. So we have the applications of BJT and FET. So the applications of BJT, it is used as an amplifier. It is used as an oscillator and also used for wave shaping in chipping circuits. It is also used as a modulator and as a detector or demodulator. While sa imuhang FET, the applications of FET is that it is a low noise amplifier, a buffer amplifier, choppers, multiplexer, or MOSFET. So, mora siya ang imuhang application sa imuhang BJT and FET. So, that is all. Thank you and goodbye.